watching this video, you're writing jam, you're a science student. I work with science students. You're writing jam this year. You will rush now and WhatsApp this number because you're talking now. These guys have already started written. They're started going ahead of you already. You want to catch up, you want to be ahead, you want to be in this category. You have to start early preparation. Let me tell you something. In your secondary school, you spent. All right, welcome. If you are here, say active. Say active. If you are with us, say active. We are doing physics. We're doing physics. We have 8 people live now. Where are the others? Let's go. Please share the link. I'm sharing the link everywhere now. Yes. If you are live, say active. Yes, very bad man, active. Yes, we have 12 people live now. Yes. We have 12 people live now. Yes. Please inform others we have started. Let us start. No time to waste today. No time to waste today. Welcome everybody. You're all welcome. No time to waste today. No time to waste. Yes. No time to waste. Yes. Those liking the live class, thank you. We have 4 likes so far. Yes. Where are the others? 5 likes. Well done. Yes, 5 likes. 18 people are live now. Yes, welcome. 18 students are live now. Yes. Good evening. Yes, Vlog. Good evening. Vlog. Say good evening, sir. You're welcome. Yes. Good evening. Yes. Yes. Good evening. Yes. We have 24 people live now. 24 students are live. Good evening, sir. Praise Evans. You're welcome. Yes. Share the link to your colleagues. Let them join. We're about starting. Share the link. Yes. We're about starting. Once we're up to 40, we'll start. Once we have 40 people live, we'll start. You're welcome. Those that are liking the live class, thank you. We have 10 students have liked, 11 students have liked the live class. Thank you. Please inform your colleagues wherever they are. Send everybody a message. Let us start. You are welcome. Yes. Where are the others? Evening greetings from yes, sir. Ebenezer, you're welcome. Samuel Clever, you're welcome. Yes, you're the one asking me on WhatsApp. Sir, where is the class holding? If I finish class, I cannot fail my class. I don't miss my classes. That's one thing you should know about me. I cannot joke with my class. You should know that. 26 people are live now. Welcome. We have 14 students. 14 students have liked the live class. Thank you for those that are hitting the like button. Thank you. If you're just joining us and you've not yet subscribed to our channel, please do so. you've not yet subscribed to our channel, please do so, do so, do so. So that anytime we come live, it will be easier for you to know. Once we hit 40, we'll start the class. Once we are up to 40, we'll start the class. We are 25 now. We are 25 now. Once we're up to 40, we'll start the class. When we're up to 40, we'll start the class. Yes, 25 students are live now. We have 16 students have liked the class. Thank you, thank you. Please get your writing material. Please, yes, yes. This someone say, hope the voice will be clear today. Are you not hearing me so far? Rayad Prince, please don't be pessimistic. Someone say, hope the voice will be clear today. The voice is clear. If you're hearing me, it means the voice is clear. Yesterday, I used the microphone. That's why I'm not using microphone today. 29 people are live now. Welcome, welcome, welcome. We have 29 students are live now. 29 students are live now. 29 students are live now. Welcome, welcome, welcome. Welcome, 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 welcome. Yes, 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 yes. Let's get started. Let's get started. No time to waste. No time to waste. Join the class. Once we are 40, we'll start. Once we are 40, we'll start. Yes, welcome, welcome, welcome. Get your writing materials ready. Welcome, 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 welcome. How many are we now? 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 We are 28. Where are the others? Where are the others? Frank Victor, welcome. Frank Victor, welcome. Thank you, Frank Victor. Thank you, Frank Victor. Okay, we are 28 now. Yes, where are the others? Where are the others? Please share the link to your departmental group. Let everybody join, please. We just need seriousness. Let everybody just join. Yes, yes, yes. Yes, 31. We are 31 now. Thank you for those that are liking the live. Thank you, thank you. We have 18 likes, 19 likes. Thank you, thank you. Thank you, thank you, thank you. Where are the others? Where are the others? We are 31 now. Once we are 40, we'll start. Once we are 40, we'll start. When we are 40, we'll start. Get your writing materials. Mute all your other social media. No distraction. Get rid of all distraction. Get rid of all distraction. Get rid of all distractions. Mute your social media. Off your TikTok. Off your Instagram. Off your TikTok. Off your Instagram. Off your TikTok. Off your Instagram. Get your writing materials ready. Please. Yes, 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 yes. Yes, yes, yes. I just plugged my phone now so we can start. I don't want it to not die in between when we are learning. So let us start. Please, where are the others? Where are the others? Someone say me too. What is me too? What's going on? Me too. Me too what? Where are the others? We have 23 people live. Where are the others? Please share the link. Share the link. I've posted the link on all our groups. Share the links to all your departmental groups. Share the link. Share the link. Share the link. Yes, good evening, sir. Yes, Prince, good evening. Michael, good evening. Welcome. Prince said active, sir. You're welcome. Yes. Please, please, where are the others? Where are the others? Where are the others? We are 26 now. The number keeps dwindling up and down, up and down. Where are the others? Let's not relent. Let's not relent. Let's not relent. Amazing Grace said active. Yes, yes, active. You're welcome. Okay, I think I will just start. I will just start. The others will join us when they come. Let's just start. We're 26. Let's start. All right, one more message from you, so we'll start. Please, can we go ahead? Give us the go ahead to start. Give us the go ahead to start. Let's know you are with us. Give us the go ahead to start. I want to say start. Everybody drop a comment. Start. Start. Yes. Drop a comment. Start. Let me see the comment. Start. Good. Yes. Almost say start. Yes. Yeah, let's go on. Praise say let's go on. Yes. Start. Let me see start. Then I start. Yes. Vlog says start. Praise says start. Yes. Others will join us. You send them the link, right? You've already sent them the link, right? So they can join us. Let us start. You're welcome. So let us start with the assignment that I gave you yesterday. You're welcome back. If you've been attending our classes from the day we started this live class, this week. If you notice, we have been very consistent now. No off days. Every day I've been meeting up, no matter how busy I am. And trust me, I'm very busy, but I make sure I meet up this class. Are we together? Yes. So we have been having this class every day for the 3 days consistently. Yes. So because the school is resuming next week, so we have to build a bit of consistency so that when school resumes next week, we can continue it very well. Do you understand? You're all welcome. You're all welcome. You're welcome. Let's get the ball rolling. Let's get the ball rolling. Thank you very much. Those that are just joining us, welcome back. Welcome back. Please, if you're just joining us and you missed yesterday's class, I send the link every day. If you missed today's class, I always send the link to the group so that people can watch and join. So please, I hope you've watched the class so that you will not draw us back and you can catch up. Are we together? We gave 2 assignments yesterday. We're looking at the Newton's third law of motion. The law looks very simple, but there are some questions under it that are not that simple. Yeah, that says action and reaction are equal but opposite. Yeah, Newton's third law says that action and reaction are equal but opposite. That is, for every action, there's an equal opposite reaction. The law looks very simple. Everybody knows the law. But the application of the law in solving physics problems, especially the mathematical aspects, is where the challenge is. And we said one key application of Newton's third law of motion is in the lift or elevator system. The lift or elevator system. The elevator lift system. The elevator lift system. The elevator lift system, yes. The elevator lift system is one of the key applications of Newton's third law of motion. And we said that a lift can either go down, right, or go up. Now we said in a lift system, there are 3 forces at play. When studying the elevator lift system, there are 3 forces at work. In an elevator lift system, there are 3 forces at work. The first force is the weight of the body in the lift system, the weight, W. The weight of the body in the lift system. The second force at work is the apparent weight or the tension in the lift system. The apparent weight or the tension in the lift system. And the third force at work is the net or resultant force. The net force or the resultant force. The net force or the resultant force. These are the 3 forces at work in the elevator lift system. The weight, the tension in the lift system, and the resultant force or the net force. The resultant force or the net force. These are the 3 forces at work in the lift system. I'll explain each of them again. The weight, of course, a lift is there to carry people up and down, right? So there's anybody that enters the lift has a weight, the weight of the body. Anybody that puts inside the lift, that's the weight of the person, W, right? Now this T, class, is the force that the lift will use to either raise you up or bring you down. The force that the lift must create. It's called the tension in the lift system or the apparent weight. The force that the lift must what? Create for this to push the body up or to bring the body down is the tension. Then the third force, the resultant force, FR. FR stands for resultant force. Is when you resolve these 2 forces, the force you get is the resultant force. The resolution of these 2 forces is the resultant force. Sometimes the relation of these 2 forces can be W minus T or can be T minus W. We use W minus T if the weight of the body is greater than the tension in the lift system. We use W minus T if the weight of the body is greater than the tension in the lift system. But we use T minus W if the tension in the lift system is greater than the weight. I hope we are following. I hope you can hear me well. Some people said they could not hear me well yesterday. I hope you can hear me well. Okay, good. We are 39 now. I hope you can all hear me well. Drop your comment. Let me see if I continue. Yesterday, some people said they could not hear me well. I think I was using my mic. My mic was breaking. Maybe the battery was low. My mic battery was low yesterday. Please drop your comment. Let's see. Let's know if you're still together. Drop your comment. Can you hear me well? Say, sir, I can hear you. Let me see. Sir, I can hear you. Those that are liking our video, thank you. We have 28 likes. Well done. Thank you. Those that are hitting the like button. Well done. Yes, we can hear you. Yes. Loud and clear. Good. See, Richard said loud and clear. Good. Frank said loud and clear. Yes. Frambito said yes, we can hear you. Yes. Okay, let me go and continue. Yes. So like I said, the resultant force can be weight minus T. That is the weight of the body minus the tension in the lift system. If the weight is greater than the tension. Or it can be T minus W if the tension is greater than the weight. Please take note. Now, from this, we derive 2 formulas. Because the popular question they should ask in an elevator lift system is what is the apparent weight in the elevator? What's the apparent weight in the elevator? And the apparent weight, also known as the tension in the lift system, is m into bracket g plus or minus a. M into bracket g plus or minus a. Why do we say plus or minus? Yesterday we told you that we can either use plus or we can use minus. We use plus when the lift is going up, and we use minus when the lift is coming down. So for up, we use plus. For down, we use minus. We use plus when the lift is going up, and we use minus when the lift is coming down. Please take note. We use plus when the lift is going up, and we use minus when the lift is coming down. Good. Now, well, there's something I did not tell you yesterday that if I don't explain it now, there will be a problem. Like I told you, this M represents the mass of the body in the lift system, this G represents the acceleration due to gravity, and this A represents the acceleration. Now, there are three possible things that can happen in a lift system. One is when the lift is going up, two, when the lift is coming down, and three, I did not mention three yesterday. So this is one, this is two, I did not mention three yesterday, and I'm mentioning three now. Three is when the lift is moving at a steady or constant speed or velocity. Lift moving at steady or constant speed. What's the name for speed? Velocity. Speed and velocity means the same thing. Just as speed is scalar, velocity is vector. When the lift is moving at a constant, steady or constant speed or velocity, if the speed or velocity of the lift system is constant, what does that mean for the formula? Class, please take note. At constant speed or velocity, what it means, remember when the lift is coming down, let me remind you of something. When the lift is coming down, I explained this thing to you yesterday. I said for the lift to come down, the tension in the lift system must be greater than the weight. Sorry, for the lift to come down, the weight of the body in the lift system must be greater than the tension T in the lift system. W must be greater than T so that the lift will come down, because W must be able to overcome the tension in the lift so it can push it down. This must be bigger than this. For coming down, the weight acts downward, remember? So the weight must be able to overcome this T so that the body can go down. But when the lift is going up, for the lift to go up, the tension in the lift system must be bigger than the weight. So the weight is trying to come down, but the tension is saying, no, I'll push you up. So this T must be bigger than weight to overcome it. Because if this weight is 500 Newton, and the tension is 300 Newton, this lift cannot go up. Because 300 Newton cannot push 500 Newton up. So this tension must be greater, at least 600 Newton, for the lift to go up. The lift must create a tension or a force that is bigger than the weight of the body for the lift to go up. But for the lift to come down, the weight of the body can be bigger than the tension, because now coming down, this W must overcome T. If this T is 600 class and W is 500, this body cannot come down, because 500 cannot overcome 600 and bring it down. For this lift to come down, this W must be greater than T, so T can be 300 here. So that when it's coming down, 500 can overcome 300 and to come down. Do you understand the analogy? So that's that. But now, I said this is case 1, this is case 2. Case 1 is when the lift is coming down. Case 2 is when the lift is going up. Case 3 is whether the lift is going up or down. Whether the lift is going up or down is case 3. Up or down at constant speed. Up or down at constant speed. Now, before I go to case 3, I want to remind you of what happens in case 1. In case 1, for this lift to come down, W must be greater than T, right? In case 2, for this lift to go up, T must be greater than W. In case 3, at constant speed, T and W are equal. At constant speed, T equals to W. Let me tell you why T equals to W. Don't forget, class, that the formula for the weight of a body is mass times acceleration due to gravity, right? The formula for the weight W of a body is mass times acceleration due to gravity. Now, the formula for tension T is m into bracket G plus or minus A, right? The formula for T, tension, is m into bracket G plus or minus A. But class, when the body is moving at constant speed, who remembers what we said about constant speed or constant velocity? Constant speed or constant velocity means that there is no increase or decrease in speed. The body is moving with the same speed. And when the speed does not change, class, acceleration is zero. Because for there to be acceleration, there must be increase or decrease in speed. If there's an increase in speed, it's positive acceleration, remember. If there's a decrease in speed, it's negative acceleration. But if there's no change in speed, steady speed, constant speed, it means the acceleration is zero. And if acceleration is zero, so it means that t is now equal to m into bracket g plus or minus 0. And g plus or minus 0, whether it is plus or minus, g plus or minus 0 is just g. It means that t equals to mg. And what is mg, class? Mg is w, w is mg. It means that t equals to w. So at constant speed, t equals to w. The tension in the lift system is equal to the weight in the lift system at constant speed, when the lift is moving at constant or steady speed. So anytime they say you find the tension in the lift system, when the lift is moving at steady speed, because some people will cram this formula now that anything about lifts, this is the formula, T is m divided g plus or minus a. But they ask you to find the tension in the lift system at steady speed, and you find out that they did not even give you acceleration. You now be saying, they did not give me acceleration, this is the formula I know. Why did not give you acceleration? Because acceleration is zero. It doesn't exist when the speed is constant. Please take note. Please take note. Are we together? Are we together? I hope we're following. Drop a comment again. Are you following the class? I hope you're following. Yes, we now have 37 people on live. We have 37 students live. Please drop a comment again. Let me be sure that you're following. I hope the board is also very clear. I hope the board is very clear. I hope you're also following. Drop your comment. Drop your comment. Let me be sure that you're still with me. Drop your comment. Drop your comment quickly. Drop your comment. Are you still there? Are you still there? Yes. Good. Good. Ike Chuku. Yes. Richard. Yes. Drop your comment. Let me see. Following. Sharp. Sharp. Thank you. Yes. Yes. Amechi. Yes. Amechi Decency. Alex wrote to me. Yes. Drop your comment. Let me show that you're still following. Yes. The board is clear, right? Okay. Yes. Right on, sir. Precious say right on, sir. Well done, class. Well done. Blessings active. Yes. Everybody, well done. Osade. Well done. 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 Let's continue. Good. Good. It means you are still following. Well done, everybody. Everybody, well done. Well done. We are together, sir. Good. Let's continue now. Yes. So now, having understood this, let us now solve the assignment. Because if I didn't explain this first, I'm solving the assignment, you might be lost. But now that I've explained this, the rest is easy. But let me remind you of something again. Don't forget that there are three forces in the lift system, right? W, T, and the resultant force, right? Class, the resultant force for this first case one, when W is greater than T, when this is coming down, W is greater than T, right? The resultant force is W minus T, because it's bigger force minus lesser force. In case 2, the resultant force is T minus W, right? Because T is bigger than W. In case 3, the resultant force, class, if T is equal to W is 0. But whatever T is also W. So if T is 50, W is 50. So 50 minus 50, 0. If T is 100, W is 100. 100 minus 100, 0. So please take note. Anytime you have to find the resultant force for a lift moving at constant speed, don't solve anything in the exam. Your answer is 0. You have to find the resultant force for a lift moving at constant speed. Find the resultant force, or the net force in the lift system is what? 0, because both the tension and the weight are equal. So 50 minus 50, 0. If it's 100, 100 minus 100, 0. But the resultant force when it's coming down without constant speed, you can find the W minus T. The resultant force when it is going up, T minus W. But at constant or steady speed, 0. Please take note. Let's move forward. Now time to solve the assignments. Now time to do. They just took light. Thank God for my backup lights. They just took light now. They just took light now. I hope you can still see the board well. You can still see the board well. Yes, yes, yes. That's why it's good to have a backup plan. They just took my light now, but there's a solar light that I always put on. Please drop a comment to show they can see the board so I can continue. Drop a comment, you can see the board, right? Drop a comment to see they can see the board. Let me continue. Yes, 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 yes. You can see the board. Good, good, good. Yes. Ikechuku said yes, yes. Yes, 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 yes. Now let us solve the question. So without wasting much time, the first question is a big lump of meat. Please, I'm not going to write the question again because I wrote it yesterday already. So we don't waste time. You should have been in the class yesterday. I already wrote the question. If you're not in the class yesterday, listen as I'm dictating it now. So you can take note of the parameters. If you missed a class the previous day, do us a favor by always watching it. Notice I always post the link of the previous class. So you should have also gone to watch it at least to get the assignment down. That will be on you now if you didn't get it. Let's take the first question. A big lump of meat of mass 5 kg. A big lump of meat of mass 5 kg. A big lump of meat of mass 5 kg is hung from a spring balance in an elevator. Once you get elevator, know that this is what you're dealing with. Elevator lift system. So mass, the meat is 5 kg. And they say we should find the reading of the balance. Last, find the reading of the balance under way of them asking you to find the tension in the elevator. Please, class. You know, one thing with most about exam is this. You will read one thing as a particular term. Now, you've read someone that has read their book, that has read tension, right? But in the exam, they are saying, what is the reading of the balance? First of all, that will first put you off, right? Exam is always there to put you off, to surprise you. I always get that, to change the terms. So that's what makes exam very difficult. You see, students have read, say I read, but I still failed. Why? What you read, that's what came out, but they changed the wordings. So you were so confused. Before you could find out that that's what they are talking about, time has gone. Because they also time you. There are two things that make exam very difficult. We just finished learning tension in the lift system, right? But look at the first question. Find the reading of the balance. They did not mention anything about tension. It only takes a smart student to know that, okay, this reading of balance, are you sure it's not tension they're talking about? Not all students will find out. And some students that don't find out, they will fail that question. And they say, the exam was hard. They did not teach us. They have not taught us this one. They have taught you, but they changed the wordings. That's why it's very important that after you have read your textbook, go and study exam question, please. Exam question will tell you the language the lecturer will ask that same topic you have read. Plus, you can finish a topic in physics vectors, and the lecturer will change the word. You look as if you have not read that topic before. That's why textbook is different from past exam question. Past exam question will show you how the lecturer is going to set that topic you have read. A student can cover his full textbook and still fail the exam. Let me tell you. Why someone that has done the exam question will do better than you. Because that person that has done the exam question is used to how the lecturer used to ask questions. He has studied year 1, he has studied 2 years ago, he has studied it 3 years ago. You know, in a past question, you have like 5 years of exam questions. Go and check the last 5 years of the exam question. What has the lecturer been setting? How has he been setting the question? Don't just stop at your textbook example. Go to the exam question. How are they going to ask me a question in this topic? That's what will make the smart students pass over the other people. So when you say people come and buy password, you think you want to say, just want to know, that password is very important for you. When we say get pass question, you know, when people were resuming last year, I was going to all the others, come and get exam pass question. If you're resuming on Monday and you still need the exam question, it's still available. Message me after this class, sir, I need a copy, keep one for me. If you don't have my number, somehow I'm surprised, but take this number, message me, sir, please keep one past exam question for me. I need to have it. Please, don't just rely on your textbook only. Your textbook alone will not be enough. You need to go and understand what is the lecturer going to set in the exam. How is he going to set the exam? And how will you know that? You can only know that by checking what he said last year, what he said 2 years ago, what he said 3 years. That's what the smart students do. There is no smart student that will take 3 or 4 years of the past exam question and will not be able to figure out what the lecturer likes setting every year. If I look at any course, I'm paying for any exam, and I go and study what the lecturer has been setting for the last 4 or 5 years, I will notice a pattern. I will say, I know what this man will bring out this year. I know what this man likes. Because past question will reveal what the lecturer likes every year to the students. Past question shows what the lecturer likes bringing out every year. So message me on WhatsApp, sir, please keep one past question for me. As you're resuming on Monday, sir, keep one. We have for all departments, all your courses, GA, everything is combined past question. Get one for yourself. Now let's continue. So you see, the mass of this lump of meat is 5 kg. Find the reading of the balance. The reading means find the tension on the apparent weights. If the elevator is moving with a steady speed, good. If the elevator moves with a steady speed, class. At steady speed, what is T? Did I tell you that T is equal to W at steady speed? And what's W? Mg, as relation to gravity. So to get the tension in the spring system at steady speed, you only need the mass and acceleration due to gravity, which is a constant. So whether they give you or not, G is known. Everybody knows G is 10 meters per second square. So T is equal to Mg because at constant speed, T is equal to W, and W is Mg, remember. So we can get our T. What is our M? 5. And our G is what? 10. 5 times 10 is what? 15 Newton. So our reading of the balance is 15 Newton. Our reading of the balance 15 Newton. I hope you are still with me. I hope you are still with me. I hope we are still there. I hope we are still there. 50 Newton. You can see it. Yes. Please, I hope we are still with me. Now, the question also has a second part. So this is the first part. So you find the reading if the elevator is moving at a steady speed. 2. They say if the elevator is moving upwards with acceleration of, now they not give us acceleration. Notice that when the first asked us to find that steady speed, they did not give us acceleration because acceleration is not needed for the first part. Because I told you that at steady speed, acceleration is what? 0. But now the second part of the question, this is the first part. The second part of the question answer, we should find if the elevator is moving upwards with an acceleration of 0.2 meter per second square. If the elevator is moving upward with an acceleration of 0.2 meter per second square, we should find the reading. When the elevator is moving upward, what's the formula for T? T is m into bracket G plus A. We use plus when going up, and we use minus when coming down, don't forget. So we're going to say T equals to m into bracket G plus A. What's m? Our m is 5 kg. Our G is 10. Our A is 0.2. This is 5. 10 plus 0.2 is 10.2. So that 5 times 10.2 is 51 Newton. 51 what? Newton. This is the tension or the reading in the balance when the elevator is going down. The second part of the question. Please, I hope we are still together. I hope we are still together. I hope we are still. Let me see your comments, please. Let me see your comment. Let me see your comment. Let me see your comment. I hope we are still together, class. So that I can take the second part of the assignment. Let me see your comment. Let me see your comments. Yes, Michael said active. Yes, Michael said active. Yes, Frank Victor said active. Yes, yes. Well done, class. Well done. Well done to those that are always encouraging us by dropping a comment. Yes, you can know this midnight. I'm just shouting on my own here. So your comments encourage us that, okay, I'm not just doing something on my own. You are there with me. Good. Favor, thank you. Favor, Frank Victor. Yes, those that are dropping comment, thank you. Well done. Well done. Well done. Joy Wisdom said active. Well done. Well done. Well done. Well done. Well done. Well done. Yes. Eleazar Bassi said active. Yes. Well done. Well done. Well done. Well done. We are together. Yes, 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 yes. Thank you for those that are always dropping comments. Because it's not easy. This is midnight. Job teaching. You don't know even people are even listening to you. You know, my neighbors are sleeping. I mean, I'm shouting. So your encouragement is very important for this kind of class. We are good. Yes, Amechi said we are good. Yes, active. Thank you for those dropping comments. Thank you. Thank you. Well done, everybody. Let's do the second question now. Let us do the second question. So where is the second question? An elevator is moving downwards with a 70 kg man. An elevator is moving downwards with a 70 kg man. So you see that they have already said it's moving what? Downwards. They're giving us the clue. It's moving downwards with a 70 kg man. Find the net force and the man's apparent weight. Find the net force and the man's apparent weight. What's the apparent weight, class? Tension in the lift system. Are you seeing? Tension, T. The man's apparent weight, T. Find the net force. What's net force? I told you about net force. Net force means resultant force. I've taught you that, right? I said there are three forces in an elevator lift system, right? There is the weight of the body in the lift. There is the tension or the apparent weight of the lift. And there is the resultant or net force in the lift. So these are three forces in the lift system. The weight of the body inside the lift, the tension or the apparent weight that the lift must produce to move the body up or to bring it down. And the third one is the resultant force. That when you resolve the tension and the weight, what you have is the resultant or net force. Please take note. Let's go back to the question. An elevator is moving downwards with a mass, with a 70 kg man. Find the net force. We're looking for the net force. And the mass apparent weight. We're looking for net force. And the apparent weight means T. If the acceleration of the lift, as the elevator moves downward, acceleration is 3 meters per second square. A is 3 meters per second square. There's one more thing we need, but they don't need to give us a constant G, right? G is 10 meters per second square. Acceleration due to gravity is 10 meters per second square. Acceleration due to gravity is 10 meters per second square. Now let's go. This is what we find the tension in the lift and the net force. Let's first get the tension T. Class is moving downward means T equals to M into bracket G. Downward, right? G minus A. Downward is minus, upward is what? Plus. Downward is minus, upward is plus. So that's T. That's only because what's our M? Our M is 70. Our G is 10. Our A is 3. So that's 70 into bracket 10 minus 3 is what? 7. 70 times 7 is 490 Newton. 490 what? Newton. So our T is 490 Newton. But they also ask us to find the net force, class. When the lift is coming down, net force is the bigger force minus the smaller force. If the lift is coming down, this is coming down, right? When the lift is coming down, who is the bigger force? Is it the weight or the tension, class? Let me see your comment. Is it the weight or the tension? Let me see if you are following. When the elevator is coming down, drop your comments, everybody. Who is the bigger force? Is it the weight or the tension in the lift? Drop your comment. Let me see if you are following. Drop your comments. When the elevator is coming down, what is the bigger force? Is it the weight or the tension? Good. Franklin Victor said weight. Yes. Ngozi said weight. Amazing Grace said weight. Good. Well done, everybody. Weight. Michael said weight. Those of you that are dropping your comments, thank you. Thank you. Thank you. Those of you that are shy, you don't want to even drop comments. You don't know that your comments can encourage us because it's not easy in this night. Thank you. Thank you. Everybody that dropping your comment. Thank you. Thank you. Joy said wait. Yes. Gamma said wait. Wait. Amechi, you said T. No, T is not the bigger force. When coming down, the weight must be bigger than the tension for the lift to come down. Yes. Every other person is saying wait. Wait. Those dropping their comments. Thank you very much. Thank you very much. Yes. Wait. Anonymous said wait, sir. Yes. 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 The weight is the bigger force. Why do we need to know the bigger force? Because the net force is the bigger force, which is the weight, minus the lesser force, which is the tension. The net force is the bigger force, which is the weight, minus the lesser force, which is the tension. So we need to go and find the weight. What is weight? W is mg. W is mg, which is m. What's our m? 70. What's our g? 10. 70 times 10, 700. Class, are you seeing that W is bigger than T? We got T as 490. Before we even saw, because see, if you understand physics very well, before you saw some things, you already know what. See that question where they said, steady speed, I know that my net force is 0. Because steady speed, T equals to W. And at steady speed, acceleration is also 0. If you understand the theoretical aspect of physics, the calculation aspect will be very easy. Remember that I was asking you in the comment just now, that who is the bigger force? And we just did the math now. Mass times G is 700. W is bigger than T. T is 490. W is 700. Because to get the net force, it is the bigger force, which is 700, minus the lesser force, which is what? 490. This is why the body can come down, because the weight is acting downward. So this 700 must be able to overpower this 490 so that it can come down. And it's possible because 700 is bigger than 490. So 700 minus 490 gives us what? 210, if I'm correct, right? 210 Newton is our net force. 210 Newton is our net force. Write down, then I'll go to another application of Newton's third law of motion. If I Newton's laws of motion, I'll go to another application of this law of motion. Yes, that's the last application, then we are done with dynamics. So then our next class we'll now go to another aspect, which is a work energy and power. We'll go to work energy and power. So let's look at the other application of Newton's third law of motion before we go today. Someone said, please, which week is the topic, sir? I don't understand. Which week? I don't understand. Someone said, which week is the topic? How? I don't get that comment. Someone said, sir, can you come again? Elua Flora said, can you come again? Okay, let me come again one more time quickly. Let me come again one more time. What part do you want me to come again? I want to know, is it from the beginning or is it the net force part? What part do you want me to come again? Flora, you said, sir, can you come again? What part do you want me to come again? From the beginning or just the net force part? Somewhere Clever said it's the weight. Okay, it's like the message is just delivering now. Okay. Let me just come again randomly. I think it's very straightforward. The tension in the lift system is M into bracket G minus A. The tension or the apparent weight in the lift system is M into bracket G minus A. So M is 70, G is 10, A is 3. So everything will go 490. That's the tension on the apparent weight in the lift system or in the elevator, 490. But it also has us to find the net force. Now to get the net force, I've already told you before. Before I started solving this, I explained this thing again, right? I said when the elevator is coming down, the weight of the body must be bigger than the tension for the body to come down. Check your notes if you are writing. Now, you get writing, make sure you are writing. Are we together? But this life class, I keep cleaning. It's what you write down that is your own. Because life class, I keep cleaning. Except you go and watch it again. So I said when the lift is coming down, the weight must be bigger than the tension for the lift to go down. So the net force is the bigger force, which is the weight, minus the lesser force, which is the what? Tension. We just got the tension here. We now let us solve for the weight before we can get the net force. What's the weight of a body? Is it not mass times acceleration due to gravity? Yes. What's our mass? 70 kg. Look at M. 70 kg. What's the acceleration due to gravity? 10. 70 times 10, 700. 70 times 10 is 7. So the weight minus the tension, 700 minus 490 gives us 210, which is the net force. Let's take the last application of Newton's third law of motion, and then we'll call it a day for today. Tomorrow will be chemistry. We have been doing physics, right? Tomorrow will be what? Chemistry. Tomorrow will be chemistry. Yes, so will be taking chemistry tomorrow. Let me do the second application for Newton's third law of motion. Then we need to now, next week we'll be including all courses, physics, maths, so the 2 maths, everything. Yes. Sometimes you can come live and even discuss your practicals for the day. Do you understand? Different things you can be doing. This live can help us achieve a lot of things. So far, we have had this live class 3 days back to back. Nobody has complained that their video is blurry, they cannot see, they cannot do this. Only yesterday, some people could not hear me because my microphone was the problem. The battery was getting low, so it was breaking. So today, I'm not even using my mic. I don't even need the mic for anything because you can all hear me very well, right? So yes. So this is, you don't know how good this live class is going to help you when school resumes. When sometimes you'll be so tired to come for physical class, this live class will save you. So you'll not be feeling bad, I've missed tutorial today again. You won't be feeling bad, okay, they will teach us in the night. Are we together? Especially when things start getting very busy. Practicals, clearance, lecture, don't worry, we've got you. We've got you. We're going to be meeting like this. At least anybody has gotten home after class, just freshen up, rest a bit. Maybe 9, 10, we'll just meet 1 hour before you go and sleep. It will just be like your personal study time. You will study, we'll do one small thing, everybody will go and sleep, continue tomorrow. Do you understand? If they give any assignment, you can meet in the night and solve it together. You don't know how the advantage of this thing. So many advantages. They gave workbook this or workbook that, you can solve it together. Yes. Yes. Class, write down. The next thing I want to look at is recoil speed of a gun. Recoil speed of a gun. Recoil speed of a gun. The recoil speed of a gun, class. The recoil speed of a gun. I hope you are still with me. 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 Someone said not all of us are offering chem. Does not mean we should not do chem now. Flora says, sir, does this mean there's no physical class again? There's still physical class. I don't know whether you people don't understand what someone is saying. There's still physical class. Monday, we have class on Monday, physical class. What I just mean is that our physical class, if for days that maybe someone was not able to attend, maybe there will be some days that maybe something happened or you had a meeting or there are a lot of factors. Do you understand? We can always still meet online. Remember, we told you guys that once your practical starts fully, it will be very difficult to be having physical class. Once your practical starts fully, it will be very, very difficult to be having physical class. Because the practical will take that remaining free time we used to use for tutorials. The practical will take the remaining free time we used to use for tutorials. It happens every year like that. Before now, we used to struggle to have a solution to that until recently when we started doing these YouTube classes and Telegram classes and the rest. Yes, we used to have issues with that because there's usually clashes. You will fix tutorial by this time. Some people will say they're having class. Infotech will say they're having COS. Engineering will say they're having engine drawing in Choba campus. Pharmacy will go there. We're having meeting. Not saying is doing a sociology, one sociology course like that. There are so many things that will make it impossible for everybody to be free at the same time. That's why we're saying that this will now be like a backup. The days we cannot meet physically. Do you understand? And even the days we meet physically, but maybe you could not attend, you can still review the tutorials that I held that day in the night live. Are we together? Yes. So it doesn't mean that you should not take the physical tutorial serious. Still take it serious. We'll still be meeting physically as much as we can. For example, on Monday we have tutorials. 2 is remaining on Monday. We are going to teach on Monday. In fact, I'm teaching physics on Monday. I'm coming to school on Monday. That's why I want us to do chemistry tomorrow because the first course we're doing on Monday is still physics. So we'll still continue physics again. So let's use tomorrow for chemistry. Maybe Sunday for mathematics. Do you get? Sunday for mathematics, tomorrow for chemistry, or Sunday for math, or tomorrow for math, Sunday for chemistry. We can switch it. I'll ask Mr. Dels which one does he want. He's the one taking chemistry. Maybe we'll take chemistry tomorrow. If he says he wants to do this one on Sunday, I will do my math tomorrow. Then he can do chemistry on Sunday. On Monday we are coming back for physics. So we have tutorials on Monday by 12. In fact, by 10 in the morning after your GS, we have tutorials. By 10 a.m. on Monday, we have tutorials. Yes, at 10:17 in one auditorium, we have tutorials. So physical tutorial will still be holding. Just like I said, there might be some days that it will be difficult. If we met in a physical class and one reason or the other we could not have the class, we say, okay, let everybody go for your next lecture. We'll meet online in the night. Very simple. Are we together? If you've not still registered for our class, please register. Please register for the class. Don't think they're going to be free forever. You have been attending our class. You see how we're teaching, and this should show you that these people can deliver this work for us. Are we together? This is how I will teach till I cover your full syllabus. Because very soon I will be making this thing a private link. I posted this link to everybody because it's general. I can still set my YouTube to only allow my members. I can select those I want into my live class. Yes, because my YouTube channel is verified. I have that advantage. If you have a verified YouTube channel, you can actually set who you want in your live class. But this one I said to make it open. So you can also make it open to everybody. I put it in public, everybody can see. If I wanted only my members to attend, I know what to do. So before we start locking the group, please send us message. Sir, please, how can we register? I like what you're doing in this class. I want to enroll in your class. Are we together? Because see, it's not easy to be teaching this thing every night just like that. If for you to be having this class every night, you must have light every day. The day you don't have light, you must on gen or solar or this or that. It needs consistent standing every night. It's not easy. So I need little support here and there. So people that have paid, they're not stupid, they're not fools. So if you've not paid, you're watching it, don't think that's going to be forever. So when we start locking it, you not say I'm wicked. Remember, I'm reminding you now. As please, I like this live class. Let me join. Because this one is even stronger than physical, because you know that any day you cannot even come for physical, you can still learn online. I know people that register with us for this online, they are working. They don't even have time to come for lectures. They are working part-time. The guy registered, he paid the money, 15K, 20K. One paid 20K success. I like this thing because I don't even have time to be coming to school. I don't even come for lectures self. So this online class, I like it. It's about chemistry or something. We have to learn some different departments, SSLT, different departments that say, I like this class, this is the best. They register, they didn't even think twice because they understand. They say, and the night, someone teaching the night every night. You understand? So sir, let me register, let me start paying small. Even if you might not have everything, sir, let me register small. Please, those people that have paid, they are not fools or they are not stupid for paying. It's not as if they have all the money, but they decided to pay. So when we start locking it, don't make us look wicked. Because very soon when I start teaching all those tough mathematics, those tougher parts of physics, I will lock the live class. Only my students will be able to attend. I will lock it. If you join, I will remove you. I can remove you. I have the advantage of removing those that have not. I will just check. I know anybody that registered, I can ask you to send me your YouTube username. So I will know who is in my live class and who has not paid. I'll remove you. So it's possible. But I'm making it open now because I want to show you that we can help you to pass your exams. We can actually help you. Seeing is believing. So please, if you want to register, message us. Message us on WhatsApp. If you've not registered on this live class, message us. Sir, please, how can I register? Let me join the live class. Don't wait till they start chasing people out. This is a new year. Budget for this man. This class will teach you more than your lecture will ever teach you. And we are following your scheme of work. This is your test. We are following your textbook. We're not teaching you off point. We are following your scheme of work, your textbook. Are we together? Now let's continue. Let us continue. Let's continue to recoil speed of a gun. Recoil speed of a gun. So message me on WhatsApp. Message me on WhatsApp. Sir, I want to register. Let me start paying small. Don't wait. Don't. So only failures give excuse. Don't say I don't have money. I beg. No, something that's going to help you pass. Let me just sacrifice and do this thing this year. Are we together? Yes. Message me and then join us. Now, recoil speed of a gun. Class, are you aware that when you shoot a gun, when a gun is being shot, forget all those things you used to watch in Nollywood. You know, if you're watching Nollywood movie, you see a police holding a gun, they're acting in Nollywood and they are shooting. And the police is doing like this. It's very, very wrong. Normally, when a gun, for a bullet to go forward, the gun must experience a recoil backward. The same thing happens if you want to shoot a catapult. What happens? Catapult. You have to pull it back, right? For whatever you're shooting to go forward, right? There must be a recoil. That same thing happens for a gun. If you watch all these American movies, you see that when they are shooting, in the acting action movie, you see that the police, they're always vibrating. They act, they recoil. So they act intelligence. They know physics. They apply physics in their acting. But Nigerian acting, they are shooting forward like this. Our police will be shooting forward like this. Watch the recoil of the people. They are vibrating backward because to show that they are acting the recoil of the gun to make it look real. But Nigerians don't act in that advanced way. So there's what we call the recoil speed of a gun. When a gun is being shot, there's a recoil that the gun experiences. So for the bullet to go forward, please forgive my gun, forgive my gun, Gun na, forgive my gun. Gun na, I'm not very good in drawing. Now, let's say this is the gun. Gun na, and this is the bullets. This is our gun. For this gun to shoot this bullet forward, the gun must experience a recoil backward. So the gun is going forward. The bullet is going. For the bullet to go forward, the gun must experience a recoil backward. That's now the speed at which the gun recoils. It's called the recoil speed or recoil velocity. And there's a formula here, class. The lecturers like setting this question a lot. It's a popular question in JAM. Class. So the formula here is simply mass of gun times the recoil speed or recoil velocity of the gun. Mass of gun times recoil velocity of the gun equals to mass of bullet times recoil velocity of the bullet. Now class, in some textbook you see that in this part of the gun there's a negative sign, and it's very correct. Do you know why negative sign? Because the gun is moving in the opposite direction to the bullet. So the bullet is said to be moving in the positive x direction, The gun is moving in the negative x direction. I hope we are not lost. I hope we are still together. Class, the longer I ask you for comment, are we together? Are we together? Please, are you still following? I hope we are not lost. I hope we are not lost. I hope we are not lost. Drop a comment, drop a comment, drop a comment quickly. I hope we are not lost. Drop a comment quickly, drop a comment quickly. I hope we are together. Drop a comment so we can continue. So the negative there you're saying is the recoil. It stands for the recoil. Oh, Michael says, sir, please come again. Thank you. You see why I need to come and be checking. Oh, someone say right on, sir. Someone say they understand. Someone say right on. Someone say come again. Please drop your comment. Whatever your favorite is. Sir, I don't understand. Sir, come again. Oh, sir, it's clear. Someone said I'm confused. Someone said, sir, please, when is the class ending? To soon end. After this, we are good, sir. Yes, Amechi said we are good, sir. Sir, please come again. Okay, Richard said come again. Let me come again. Let me come again. You see, without your comments, I wouldn't have known the importance of night class. Now, you can easily tell me, oh, sir, I don't understand. So let me come again. As I said, look up. This is the gun and this is the bullets. The subtopic is recoil speed of a gun. Recoil speed of a gun. For this gun to shoot this bullet forward, this gun must experience a recoil backward. I explained it in catapult. Some of you have shot a catapult before. Why do you think they used to draw it back for you to go for the bullet or whatever? What's the name of the bullet of the catapult? See the quiver or whatever. To go forward, the arrow. Whatever, even if it's an arrow you want to shoot, anything you want to shoot, you push it back, right? Before it can go forward, the tool that is shooting it must go backward, the recoil. The same thing applies to a gun. For this gun to be able to gather, why is the gun experiencing that recoil? For it to be able to gather enough force to push the bullet forward. The recoil lets the gun to acquire enough force to push the bullet. So the more the recoil, the more the impact of the bullet. That's why when the bullet enters, it pierces inside. Because the gun experiences a strong recoil backward. Are we together? So the recoil speed, they usually ask us to find the recoil speed of the gun. At what speed does the gun recoil for the bullet to be shot forward? It's called the recoil speed of the gun. And the formula is mass of gun times velocity of gun equals to mass of bullet times velocity of bullet. Mass of gun times velocity of gun equals to mass of bullet times velocity of bullet. Now I said, why is this negative sign here? This negative sign here is there because the gun and the bullet are not going in the same direction. So they cannot both have positive. The gun is going backward. If you draw a x coordinate like this, and this is your origin. From the origin to the left is minus. From the origin to the right is plus. So this is the gun's movement. The gun is coming like this, while the bullet is going like. This is why there's a negative sign in the gun side and there's a positive sign in the bullet side. So class, usually, if you ask you to find the recoil speed of a gun, your final answer usually carries a negative sign. Yes. So you can solve the question on recoil speed of a gun and your final answer is 5 meters per second. And the lecturer will intentionally put 5 meters per second and put minus 5 meters per second. They'll put 5 meters per second in option A and put minus 5 meters per second in option D. Because you are rushing and you're under exam pressure, because you just saw 5 is 5, you don't rush to option A. But smart students will count down and say, no, this is recoil. They have explained this before, that recoil means what? Negative, the gun moves in negative direction. So my final answer, my final recoil speed is not just 5, it's minus 5. Be very careful, very careful. This is the formula for recoil speed of the gun. So this mg means mass of the gun. So mg represents mass of the gun. Vg represents velocity of gun. Mb represents mass of bullets. And Vb represents velocity of bullets. So mass of gun, velocity of gun, mass of bullet, velocity of bullet. Now it's time to take questions. It's time to take questions. It's time to take questions. Yeah, Osadebi said following. Well done, class. Well done, class. We have 50 people that are live. Thank you for those that are liking our video. Thank you. Those that are dropping the like comment. Thank you. Thank you. We have 43 likes. 43 likes. This is good. This is good. It shows that you're following the class and you're understanding the class. 43 likes. 43 likes. If you are just joining us, you have not subscribed to our channel, hit the subscribe button so that when we go live on any of our classes, you'll be the first to know. Your phone will notify you that they are live. Oh, are we together? Yes, let's take some questions before we. What I will do, I will give some questions that will now serve as assignment for our next class. That will serve as assignment for our next class. Just like we have been doing, we'll teach something, then we'll give assignment and continue the next class. Let's look for a question quickly. Okay, let's go. A revolver of mass 6 kg. A revolver of mass 6 kg, same thing I'm talking about. I just explained gun, but your first question is revolver. Someone said, I've never taught me revolver. Whether it's revolver, whether it is gun. I've once seen a question in years, I say a cannon. A cannon. They will not even use gun. There are different types of gun. A revolver, that is still the same formula. So someone must have read gun and say, which one is revolver again? So take a revolver of mass 6 kg. Let me write the question down. A revolver of mass 6 kg. Releases a bullet of mass 0.05 kg at a speed of 200 meters per second. Find the revolver speed of recoil. Find the revolver speed. Class, once you hear speed of recoil, even if they did not use gun, whatever, just know that it's the same, it's that formula they're asking you. Find the revolver speed of recoil. Find the revolver speed of what? Recoil. Class, this assignment is where we're going to stop today. And then in our next physics class, we should be on Monday. It means that on Monday, those people that will come to our physical class will be shocked. I say, when I learn this one, I will just start solving this in the physical class on Monday. Sir, how, now? Then they'll know that they are still behind. They'll know that, you know they learn. So you just do WhatsApp group, you know, they check what they happen. Yeah, this will be their punishment on Monday. I want to use this assignment to shock them on Monday. So on Monday, when I come for physical class, 10.781, everybody just ask surprise. We're going to come in and say, okay, assignment we gave in our last class on Friday. Sir, which sir? We have been on break. Which one is Friday now? I'll say, yes, we are learning spiritually. Are we together? We're going to say, we have been learning spiritually. We have been meeting in heaven, learning. All of us. Yeah, we're going to shock them so that they will sit up and say, oh boy, so I've been missing. So if some people join a group, they will never open the message in the group. They will just relax like that. Some people have one paid, but they never open the message in the paid members group. They just sat down like that. Very, very bad. So on Monday, because we're having physics on Monday, when we come, we're having physical class on Monday. School is running on Monday, everybody should be around. I'll be in school. I'm going to teach physics. We're going to continue from here on Monday. So tomorrow will either be chemistry or maths. We'll update you on our groups. Tomorrow will be chemistry or maths. If Sadesi teaches chemistry tomorrow, I'll teach maths on Sunday. Are we together? Alright. I hope we have learned something today. Let's see your comment before we go. I hope we're all good. I hope we're all good. Yeah, someone said everywhere go first blow. Everywhere go first. Yeah. Depends everywhere. On Monday, eyes go first blow, Abi. Exactly. They go say, sir, when we learn all this one now, waiting to happen, we did on break. Because some people, they just thought that school has gone on break. They did not even open their WhatsApp message at all. They don't even check group. They also went on break like that. What time on Monday? Monday will be by 10 a.m. Monday will be by 10 a.m. Monday will be by 10 a.m. Someone say, hope it's chemistry. Yes. Chemistry will be tomorrow, then math will be on Sunday. But if chemistry did not hold tomorrow, then chemistry will hold on Sunday, math will hold tomorrow. Anyone, we'll let you know on our group. You're all on our group, right? Thank you. We have 50 likes. Wow. This group, 50 people liked our video today. Someone said, will there be lectures on Monday? Obviously, school has fully resumed. School has fully... Someone said, I dropped a question earlier. I don't know, is there a way of me checking the former comment? Let me see. Oh, there's actually a way. I can actually scroll down all the comments that have happened so far. I didn't know that before. Wow, this is interesting. Okay, please, the person that dropped the question, just send it to me on WhatsApp, Send it to me on WhatsApp. Send it to me on WhatsApp. All right, everybody, good night. See you on Monday. I can't wait to see you all on Monday. Yes, see you on Monday. I hope you have eaten well, because school will come and dry your blood again, Uniport is waiting for you, ready to dry all your freshness. Uniport is ready to take it back on Monday. I hope you enjoyed well, Yes. See you on Monday. Good night, everyone. See you on Monday. But live class still continues tomorrow. Remember, chemistry. Yes, yes, yes. Good night, everyone. See you on Monday. See you on Monday. So Monday we have our physical class. Take care, everybody. Good night. See you on Monday. See you on Monday. I will see everybody's New Year face. New Year face on Monday, Abby. New Year face on Monday. New Year face on Monday. Someone said so quick. Yes, yes. This night on is so quick. Yes. I just wanted to just do this. The most important thing is the consistency. Let us be consistent. Let us be consistent. Yes. If you continue this every day, even if it's one topic we take every day, you will cover a lot. Because imagine just so it's not about how much, it's how well. It's how well. Yes. All right. Good night, everybody. Thank you very much.